All right, let's do another one of these pressure problems. So in this particular one, we're going to be below the surface of the ocean. All right, so keep in mind at the surface of the ocean, we have 1 atmosphere of pressure. Now, you don't really experience that. I mean, there is the 1 atmosphere of pressure, but our bodies, we have 1 atmosphere of pressure inside, and so there's an equal amount of pressure inside and outside. And so when you're on the surface of the where you're in a boat or something like that at the surface, somebody at the surface of the water, they have equal pressure. All right, now let's take that same person and we're going to immerse them in the ocean. Let's go down about 50 meters, and we're going to use this to calculate the pressure. Now, just to let you know, this pressure right here is what we call the gauge pressure. So if you were to add this to the 101.3 kilopascals, right? Remember that's the you could add the atmospheric pressure. So this is the pressure, the atmospheric pressure, atmosphere. All right. Anyhow, that's supposed to be an M. Sorry, is of course 101.3 kilopascals. All right. So here let's turn to our problem. So since we're in the ocean, the density of the ocean, or I wrote C. That's supposed to say C. The density of the ocean is slightly greater. Let's say it's the average salinity, and that makes the density at 1,025 kilograms per cubic meter. Remember, fresh water, it's 1,000. And if we're at a depth of 50 meters, okay, so we're going to put our person down here. So here's our person. There's our person. 50 meters down. What's the pressure on them? Now, keep in mind, we're not going to add the pressure of the atmosphere to this. This will be like the gauge pressure, the pressure that they feel. All right. So the pressure, we're going to use this equation right here, and so the pressure, which technically is called the gauge pressure, is going to equal the density of the seawater, which is 1,025 times in kilograms per cubic meter, times the acceleration due to gravity on the surface of the Earth, which is always 9.8. I'm going to leave the units off. Meters per second squared, and the depth here is going to be 50 meters. All right, so this will give us an answer in Pascal, right? In Pascal, but I want to convert that into atmospheres. All right, so I want to know what the so if you're at a depth of 50 meters, how many atmospheres do you feel? All right, so keep in mind, at the surface, you don't really feel I mean, it's true that you do experience this 101.3 kilopascals. That's absolutely true at the surface of the ocean, but we don't really feel that because our bodies have that same pressure inside. All right, but when you get into the ocean, you really feel that crushing. I mean, you've experienced this probably at the bottom of a pool. I mean, you get in a pool that's maybe I don't know, 5 meters deep or something like that, and if you can swim down to the bottom, you really start to feel that pressure. All right, so how much pressure is it going to be? First we'll calculate it in Pascal, and then we'll convert it to atmosphere. All right, so that's what we're going to do. All right, so the first part is relatively straightforward. All right, so let me get my calculator going here. All right, let's clear that. All right, so here we go. So it's 1,025 because that's the density of salt water times 9.8, which is the acceleration due to gravity on the surface of the Earth, and then times 50, right? Because you're 50 meters deep, which is pretty deep, in anyhow. So you can see this is over 502.3. So I'm going to do it in kilopascals. So 502. So here, let's write that 502.3 502.3 kilopascals, all right? So the kilo, of course, means 1,000 pascals. And the reason I changed it to kilo is because, remember, we're converting it into atmospheres. And, of course, one atmosphere. Okay, so sorry, let me write this. This is 502.3 kilopascal, all right, kilopascals. And I know that that one atmosphere is 101.3 kilopascals. All right. So the kilopascals cancel here, and so that'll tell us, when you're 50 meters below the surface of the ocean, this is what you feel. Okay, so let's get this number. Well, I mean, I have the exact number right here, so I'm just, here we can change it to here. Let me change this. All right, so 502.3. All right, and then it's kilopascals, so I mean it's the kilopascals will cancel, but I'll anyhow. So it's divided by 101, divided by 101.3. All right, so this is how many atmospheres. So you would feel almost 5 atmospheres of pressure at that depth. All right, almost 5 atmospheres. And, this becomes important when you start to think about like submarines and things like that. I mean, how much pressure can the human body take, before things get really bad. All right, so the answer here, let's see, I'm going to round it to, let's go 2 places past the decimal. So so it's going to be 4.96. So it's going to be 4.96 atmospheres. All right, so there's a nice little problem for us. All right, next I'm going to turn to waves. On chapter 24, there's also wave motion, and so I want to do a couple problems with waves. All right, so here's our general equation for waves. So the velocity of a wave, and this is true for any wave, is equal to the wavelength times the frequency. The wavelength is measured in meters. Okay, so this is the meters, and the frequency is measured in units. So we always put the units in parentheses in units called hertz, which is really just 1/seconds. And notice the velocity is also equal to the wavelength divided by the period. All right, so again, the wavelength is in meters, but in this time the period is seconds. And of course, there's a relationship between frequency and period. So the frequency is just simply the reciprocal of the period. All right. So we just use the term hertz for it's really cycles per second, but you could just think of it as cycles. All right. So let's do this problem. We're going to figure out what the frequency is and what so we're going to figure out f. Right, so this is our problem. F equals ? And the V equals ? And our problem says the lambda, the wavelength of the wave, is 75 centimeters, and the period is 1.3 seconds. So it takes, so the wave is going by like this. So here's our wave, and the distance between peak to peak, or crest to crest again, is this. It means the same thing. That's what lambda is, right? Lambda is the distance between. It's really where the wave repeats itself. So you could do trough to trough. That's perfectly fine. It's the same value. So lambda is, in this particular case, 75 centimeters. Although, we don't want it in centimeters. It should be, as it says up here, in meters. And the period is fine. The period is 1.3 seconds. So it takes 1.3 seconds for one of these full cycles to go by. All right, so the frequency, all right, let's do that one first because it's the simplest one, is just the reciprocal of the period. So it's just 1 over 1.3 seconds. And so this is going to be in hertz. All right, so this is going to be a small number. So let's see. So it's going to be 1.3. And it's, you could just say 1 divided by that, or, if you have a reciprocal button in your, many calculators have the x to the minus 1. This one, it's 1 over x. All right, and so that's it. So let's round it to 2 places past the decimal. So it's going to be 0.77. All right, so that's the answer. That's the frequency, 0.77 hertz. All right, and what that means is one cycle. It completes one cycle in 0.7. Well, I'm sorry. The frequency, the number of cycles that go by per second is 0.77. So it doesn't even complete a cycle, one cycle in 1 second. All right. Anyhow, so let's get to the velocity. So the only thing is we have to change this from centimeters to meters, but that's pretty easy to do. So I know that lambda is 75 centimeters, but I know that in 1 meter there are 100 centimeters. Right, so the centimeters cancel, and so this is just 0.75 meters. All right, so that's 0.75 meters, and it's 1.3 seconds, right? So here, let's see. I need a little bit more room. So 0.75. I got to remember this. 0.75 and 1.3 seconds. All right. So here, let's do that. All right. So lambda's 0.75. 0.75 meters, and the period t is 1.3 seconds. All right, so the velocity of this wave is going to equal the wavelength times divided by the period. I mean, you could say the wavelength times the frequency. That's the same thing. All right, so it's lambda, which is right there, times divided by the period. All right, so it's going to be it's the distance divided by the time. The distance in meters divided by the time in seconds. 0.75 meters divided by 1.3 seconds. All right, so let's see what our answer is. Get my calculator here. Oh, I can't find it. Hold on. I'm losing the mouse here. All right, here we go. All right, let me move this over a little bit so we can see it. So it's going to be 0.75 divided by 1.3. All right, so the velocity of this wave, let's round it to 2 places past the decimal, is going to be 0.58, right? Because it's 0.576, which if the third digit is greater than 5, we round up, right? So 2 places past the decimal is 0.5. 0.5. Let's see. Sorry, I didn't mean it to go away. 0.58, right? 0.58 because it's 7 and the 6 is afterwards. So 0.58 meters per second. All right, that's supposed to be a 5. All right, so that's the velocity of this wave, 0.58 meters per second. And that's how you would do these kind of problems. All right, yeah. So that's a good example for doing these wave problems. And all right, let's see what else. Yeah, I think that's about it.